Welcome to Maths with EJD. Gradually drawing to a close on the idea of coordinate geometry. In this video, we are focusing on map-based tasks in coordinate geometry. In the previous video, we had considered coordinate geometry in real life, and we saw things surrounding mapping, working with global positioning system and things like that, where we saw how to make a trip from Tokyo to Osaka, following the latitude and longitude and things like that. Here we are focusing strictly on map-based tasks in coordinate geometry. Okay. By the end of this note, we should be able to represent real-world map locations as coordinate points, compute distances, midpoints, and gradients between two or more locations, determine bearings and direction angles for navigation, find areas of land plots or regions from coordinates, apply coordinate geometry to problems in science and engineering, implement all these tasks using Python for automation. Okay, let's look at the concept of coordinate plane. Okay, so a map can be modeled on a Cartesian coordinate plane. The x-axis can be seen as the east-west direction, while the y-axis can be seen as the north-south direction. And of course, when we talk about a map, right, it talks about the Earth and east-west. I think east-west is longitude, right, and north-south is latitude, something like that. And then the origin 0,0 is the reference point, e.g., the city center or GPS base, based on whatever we might be considering. Okay, so a scale converts map units like cm, grid units to real distance like meters and kilometers. For instance, if 1 cm is equal to 1 kilometer, then that means that a 5 cm line on the map is the same thing as 5 kilometers in the real world. So because a map is like a model of reality, right? So 19.2, we talk about core coordinate geometry formulas. We've been interacting with these kind of formulas since the beginning of this playlist, right? So core coordinate geometry formulas, of course, first of all, we need to talk about the distance between 2 points. So for ax1, y1 and bx2, y2, the distance AB is simply square root of x2 minus x1 squared plus y2 minus y1 squared. And then we have the midpoint between these 2 points, which will simply be m equals x1 plus x2 over 2, y1 plus y2 over 2. And then we have the gradient and the slope, that's m, which is equal to y2 minus y1 over x2 minus x1. The slope tells how steep a road or path is, which is crucial for road design and drainage. Okay. Then we have the idea of bearing. Bearing relates with angles. Like how is another place, how is a point B relative to point A, something like that. How do we get to Tokyo? How do we get to Osaka from Tokyo? Like what we saw in the last video, and we discovered that Osaka is like south 74 degrees west, something like that. So the bearing of B from A measured clockwise from north can be taken to be theta equals arctan of x2 minus x1 all over y2 minus y1, like this, so we can get the angle. So if the numerator is positive eastward, the bearing lies between 0 degrees to 360 degrees, right? So that means you're starting from the north, approaching the east. That's what that is about. Then we have the equation of a line, which we've dealt with a lot of times. There are different ways you can represent the equation of a line, depending on the information you have. In this case, imagine if we have a slope and we have a point, then we can have the equation of a line to be y minus y1 equals m equals x minus x1, used for modeling roads or pipes between two coordinates. So we can get that. Then we have the area of a triangle. For if you have a triangle with vertices A, B, C, A is x1, y1, B, x2, y2, C, x3, y3. The area, like we've always seen, is 1 over 2 absolute value of x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. Now, the easy way to do that is to put it in matrix format, as usual. So the area, we always know the area to be half into the determinant of x1, y1, 1, x2, y2, 1, then x3, y3, 1. By looking for this, we get the area of that triangle based on all the coordinates like that. Okay. So having taken care of that, We can also talk about section formula. So if you want to find, if you have you have a road or a line and you want to divide it into portions. So for instance, imagine that you are awarding a road to two contractors and you want a contractor to take a particular, you want to divide the road AB in ratio M to N, still following the fact that A is X1, Y1 and B is X2, Y2. So point P dividing AB in ratio M to N. I think this is one of we must have taken care of this in the first or second video earlier, but now we are looking at practical applications of these things. So we have so that portion where the division is done is mx2 plus nx1 all over m plus n, comma my2 plus ny1 over m plus n. Of course, this happens if you are talking about, if you want the division to be internal. If it is external, signs change. Okay, so let's look at an example. Let's look at example one where we have distance and midpoint like that, distance and midpoint. The problem is this: on a map, the airport is at A 2,3 and the harbor is at B 8,11. You know, so you're talking about the coordinate system, right? So each unit is equal to 2 kilometers. Then you want to find the distance AB to the midpoint and its interpretation. So the distance, of course, we know is AB. That's square root of 8 minus 2 squared plus 11 minus 3 squared. That's square root of 6 squared plus 8 squared, which is 36 plus 64, which is 100. Square root of 100 is 10. So, and since whatever the 10 units you have here is, 1 unit is 2 kilometers. So the real distance will be 10 times 2, which is 20 kilometers. And talking about the midpoint, we have M equals 2 plus 8 divided by 2, and 3 plus 11 divided by 2. That's 2 plus 8, 10 over 2, 5. Then 3 plus 11, 14 over 2. That's 7. The interpretation is that the point 5,7 lies midway between airport and harbor, and possible location for a transport depot or service hub. Maybe you get to exchange things between the airport and harbor like that. Okay, we'll look at example 2, where we talk about slope and bearing. So we have an observation tower at A with coordinate 2,1 and signal post is B 7,5. So you want to find slope, then B, bearing B from A. So the slope is simply y2 minus y1 all over x2 minus x1. That's 5 minus 1 all over 7 minus 2. That's 4 over 5, which is 0.8. Now, to look for the bearing, you just simply, the bearing of B from A now. So theta will be arctan of, now it will be x2 minus x1. That's 7 minus 2, which is 5, all over y2 minus y1. That's 7, all over y2 minus 1. That's 5 minus 1, which is 4. So if you take arctan of 5 over 4, you get 51.34 degrees. So hence the bearing will be 0.51 degrees clockwise from the north. So if you want to do it in terms of cardinal system, so that'll be north, 51 degrees east, okay? Because it's clockwise. So we go for example 3, where we talk about area of land plots. So you want to find the area of land plot. Imagine that a land has 3 corners, so it has like a triangular shape or something like that. So A is 1, 2, B is 6, 4, C is 4, 8. You want to find the area. So the solution is area 1 over 2 into this whole thing, and the answer is 12. 1 to 6 for 4, 8. I think we've done this before actually. So 1 to 6 for 4, 8. Let me just go for that, since we're already talking about it. 1, 6, 6 for 4, 8. So here now, okay, let me just use what I have. Area is 1 over 2, 1, 6, 1, 6, 4, 1, 4, 8, 1. So this is x1, x2, x1, y1, x2, y2, x3, y3, like that. So the area is simply half into, so I will just go straight instead of wasting time. So here now we have 1 here into cover this and this. We have 4 times 1, 4, minus 8, that's minus 4. Okay, so we have minus 4 like that. That's plus 1. We could actually come down like this, or we can go like this, anyhow you want to go. But I'm used to going horizontally. So the first one has plus because 1 plus 1 is 2. So once the number of the sum of row and column position is even, the sign will be positive. If it's odd, the sign will be negative. So this is row 1, column 2. That's 3, which is odd. So that means we have minus 6 into, cover this and cover this. We have 6 times 1, 6, minus 4 times 1. That's 2. Okay. So it means this will just be 2. Then, of course, this is row 1, column 3. That's 1 plus 3, 4. That's even. So the sign will be positive. 1 into, okay. So cover this and cover this. So you have 8 times 6, 24. No, 8 times 6, 48. 48 minus 16. 48 minus 16. That is minus 48. 48 minus 16. 48 minus 16. That's 32, right? That's 32. So this is 32 here. So we can move on with the rest. So the area now is 1 over 2 into 1 into minus 4. Okay, we can go straight. This is minus 4 minus 12 plus 32. Okay, so that is 32 minus 12 is 20. 20 minus 4. 20 minus 4. 32 minus 12 is 20. Is 20. Okay, 20 minus 4 is 16. So area is, are we good? This is minus 4 minus 12. That's minus 16. Okay, that's half into 16. So A is 8. Really? Is that the right answer? I think the answer there is 12. So something should be wrong there. So this is 12. 8 minus 3. So let me check again. I guess something might be wrong right here. So again, this is plus 1 into 4 minus 8. That's minus 4. Then we have minus 6 into 6 minus 4. That's 2. Maybe did I get the coordinates wrong? This is 1, 2, 6, 4, 4, 8. 1, 2, 6, 4, 4, 8. Yes. 1, 2. 1, 2, 6, 4, 4, 8. How did I get 6 there? Okay, so that's where the issue is. 1, 2, 6, 4, 4, 8. So 1, 2. Okay, so that's where the trouble came from. So I have this. So 1 is fine. 1, cover this, that's minus 4. Then minus 2. Minus 2 now into 2, correct? Plus 1 into, cover this and this, that's 48 minus 16, that's 32. Okay, I think that's it. Minus 4 plus 32. So 32 minus 8 is 24, I think. Yeah, that's 24. So this is minus 4. This is minus 4. So 32 minus 8 is 28. 28 minus 4 is 24. So now this is 12. Okay. So that's where this is actually 12, like that. Okay. So it was that point that was the problem. Okay. So we have that now. So if 1 unit is 100 meters, then area will be 12 times 100 squared, which is 120,000. So that's 12. We're talking about area. So that's 12 times 100 times 100. 100 times 100 is 10,000. So 12 times 10,000 is 120,000. So 120,000 meters squared is 12 hectares of plot, 12 hectares of land. So if you have those coordinates, that's what you have. Okay, so we talk about points dividing a line. So find coordinates of P dividing AB into ratio 2,3, where A is 2,3 and B is 10,9. So the solution P, of course, we use that formula of the 2 times 10. That's 2 times 10 plus 3 times 2. So this 2 times 10 plus 3 times 2 all over 2 plus 3, and we get 26 over 5, 27 over 5, like that. So that's like 52 over 10. That's 5.2. And 27, okay, yeah, we still have something there. Then 27 over 5 is 54 over 10. That's 5.4. So that's why we have this here. That's the point dividing the line. So if imagine you are awarding the road AB to two different contractors, okay? So it means the first contractor will take 5.2 kilometers, while the second one takes 5.4 kilometers. So let's look at engineering and scientific applications of map when we talk about map-based tasking, coordinate geometry. So of course, we've talked a lot about things relating to geography, maps, GPS, and all the rest of them. So geographical information systems, GIS. So we have for spatial data, you have coordinates for mapping terrain and urban infrastructure. You have civil and structural engineering, road gradients, bridge alignment, drainage profiles rely on coordinate geometry. Then you have mechanical and aerospace engineering. You have trajectory design, robots path planning, and drone navigation use coordinate models. In the last video, of course, you saw how we're able to generate a kind of trajectory if you're moving from Tokyo to Osaka. So, and if you check at any point in time, like if you're navigating, maybe using a plane or drone or whatever you're using, you can know if you are out of line or not. And you have physics and environmental science. So we have vector fields, projectile motion, and pollutant dispersion are mapped using coordinates. So we saw vector fields and projectile motion in I think the last video. So let's look at some Python implementation. So I won't waste time with the codes. So if you are interested in the codes, you can explore. Okay. So when we talk about distance, midpoint, and slope, that's pretty easy to come by. Imagine that you have, so we define a function generally. We have map metrics, A, B, scale is 1. So that means whatever you get is what it is actually. So this return distance, map and real, and midpoint and slope between A and B. So imagine you have A to be x1, y1, and B is x2, y2. The distance between the two, of course, is the square root of x2 minus x1 squared plus y2 minus y1 squared. And the real distance is equal to distance times scale. So if your scale is 50 to 1, like for 1 cm, you have 50 kilometers. So you can change the scale right here. So you have a default scale, but if you don't want that scale, you can always change it. So then, of course, the real distance is distance times scale. Midpoint, of course, x1 plus x2 divided by 2, y1 plus y2 divided by 2. And the slope is y2 minus y1 all over x2 minus x1. Then you can return distance, the real distance. This is the map distance. This is the real distance, the midpoint and the slope. So all you just need to do is supply coordinates for A and B. Okay? Once you can supply that, then you can then run that, and it will give you the distance, the midpoint, the real distance, midpoint, and slope, which is equal to map metrics AB. So to take this A and B in, and now the scale here is 2. So if you don't change the scale to 2, it will use the default scale. So, and then it will print distance in map units and distance in real kilometers, and to take the midpoint and slope. So you can decide this. So it's more like you're taking metrics for 2 points on your map, like that. Okay, so in this case now, using 2, 3, and 8, 11, of course, the distance is 10.00. That's the distance on map. In real distance, because the scale is 2, just multiply this 10 by 2 and you get 20. And the midpoint is 5.0 and 10, 7.0. And the slope is 1.33. So if we change this one to 12, and this is 30, and maybe this is 80, and 11 like that. So if you run this again, it gives you this new deal. So that's how you get it. So let's talk about bearing calculation. Of course, for bearing calculation, it is arctan. So between A and B, it is arctan of x2 minus x1 all over y2 minus y1. So, and you get the degree. So here now you have A, x1, y1, B, x2, y2. The angle is arctan of x2 minus x1 all over y2 minus y1, like I said the other time. So if the angle is less than 0, then it means that the angle is plus or equals 360 degrees. So if you get a negative angle, you have to add 360 to it to make it positive. I mean, that's a standard practice in trigonometry. So in this case now, if you have distance AB 21, A is 21, B is 75. So you can find the bearing of B from A. And then we just run that and we get the answer spewed out 51.34. So imagine if I change this one to 21 and this is 12, Then I change this one to 17, and this one is 50. No, I mean, randomly. So you see the angle is, so definitely this must have been negative. And then if you add 360 to it, it gives you 353.9 degrees. So this is something between north and west. So whatever, if you subtract this from 360, whatever is left, you can say north, that angle west, like that. Okay. So because it is in the fourth quadrant, by the way, in the first quadrant is northeast, second quadrant, if we go clockwise, right? So first quadrant is northeast, second quadrant is southeast, third quadrant is southwest, and fourth quadrant is northwest. If you go from north and you go clockwise. So area of triangle and plot visualization. So for area, you have ABC, X1, Y1 is A, X, Y2 is B, X3, Y3 is C. And we have the formula right here, 0.5 into X1 into Y2 minus Y3 and so on and so forth. And you fix A, B, C, whatever you call them, and then you can visualize them if you like, and then you calculate the area based on the formula. So there you just get, okay, I didn't run that. So you visualize it and you get the area to be 12. I think it's what we did previously. That was 126,448. That one we calculated, and this is the triangle and its area right here. So, and then this is east-west, right? And this is north-south. So you can automate some tasks, with some map tasks based on this. So like if you want to, so this code now is open. So anything you want to do, you can just, you just decide what you want to do and go for it. So you have simple CLI for multiple map computations. So you want to print map-based geometry task. So A is a tuple. Tuple means you can impute as many as you want. So it tells you to enter A, X, comma, Y, and B is the same also. And then you scale, you can determine the scale. Do you want it to be 1 to 20 or something? Then that gives you D, R, D, mid, and all the rest. The distance, real distance, midpoint, and the slope. And that'll be so, and that's still within the map metrics we had defined previously, taking A, B, and scale. So it's still, so this code now is still built on what we defined in this particular place, right? So it's this code is dependent on that part. So if I run this now, it ask me enter. So if you have any random points you want to use, you can just say, okay, let this be 3,4. 3,4 taken, and then maybe I say 7,9 taken, and then scale real kilometer per map. So let me say 20, that's let's say 25. And then it just takes that and it computes the distance between the two to be 160.08 kilometers. The midpoint is 6.5, and the slope is 1.25, and the bearing is 38.66 degrees. So I run it once more and supply another set of points. Let's say I have -7, -8, all right? And then I have 11,22, like that. So the scale I want it to be 500, So now we have 344.99 units, and that means 17,492.86 kilometers. The midpoint is 2.0, 7.0. The slope is 1.667, and the bearing is 30.96 degrees. So you can keep doing that as much as possible. In summary, we see that coordinate geometry enables precise mapping of spatial data in science and engineering. By combining formulas for distance, midpoint, slope, and area with Python automation, engineers can design and analyze complex systems from roads and bridges to robotic navigation and GIS terrain maps. So, as usual, we have some 10 practice questions to try your hands on to see if you really get the gist. Okay, so you have villages A 4,2, villages A 4,2 and B 10,12. 1 unit is 3 kilometers. Find the real distance. All you just need to do is take the square root of 10 minus 4. That's 8 now. That's 8 squared. Yep. And then y2 minus y1 squared. That's 12 minus 2. So you have 8 squared plus 10 squared. Square root of 8 squared plus 10 squared. That's square root of 164. Whatever you get from that, then you multiply by 3. And that will give you the real answer in kilometers. So with this, we come to the end of this interesting video about map-based tasks in coordinate geometry. After this, there's just one more video, except something else comes up. As far as coordinate geometry is concerned, the next video uh puts an end to it, except there's a request or I discovered there's something else I need to talk about. All right, let me know. Thanks for listening. Let me know how helpful this is for you. And if there's something you like on the trial, feel free to let me know. Okay. If you have subscribed already, I thank you so much. If you have not subscribed, of course, you don't want to miss out on anything again on this channel. So go ahead and subscribe and hit the notification bell so you can always get alerted each time a new video is released. Having done that, of course, you can also take things higher by becoming a member of the channel. Click on join, and you can find um, 3 levels of membership with some special privileges. Ultimately, don't forget to comment, like, and share so that more people can have access to the great content I have going on here. Till I come your way again, keep doing math right. Bye.